And so let us start. So today we will be starting with a new topic, that is the numerical methods and computer programming. Right. So this is actually one of the very easy topic. So many people actually know this already, most of the people, right? So you cannot find an easier topic than this. So this is actually so everybody could able to easily understand this particular topic. But only one constraint is that actually numerical methods actually you have already studied in your graduation. That's why actually you will not face any difficulty. But computer programming actually we have actually two different sections in computer programming. One is actually the Boolean algebra, and another is algorithms and the flowcharts. So this actually computer science people actually will be very much aware of it. But other people also, those people who study digital electronics and then computer programming, so that people actually they don't face any difficulty. But people from the graduation or the degree, normal degree actually, they may not be studied this one. That's why actually they need to learn that. Other than that, actually this topic is one of the easy topic. Okay. And in this actually, let me cover some of the basic questions. One is actually what is the syllabus? And the second one is what are the books? To follow, right? And the third one is, right, weightage of this particular topic. Right. And the fourth one is important sections. Important sections. And fifth one, approximate number of hours. Right. So these are all the questions actually I wanted to cover, and if you wanted me to add any questions, you can ask me. Right. And now actually let me list down the syllabus for this particular topic. So the syllabus is just write it. So numerical methods. Right. In the numerical methods, it is solution of algebraic and transcendental equations. Equations and of one variable by bisection, regular policy, and Newton-Raphson methods. By bisection, regular policy, and Newton-Raphson methods. Solution of system of linear equations by Gauss elimination method. Linear equation by Gauss elimination and Gauss-Jordan, Gauss-Seidel. Solution of system of linear equations by Gauss elimination Gauss-Jordan Gauss-Seidel methods. Gauss-Seidel methods. Newton interpolation, Lagrange's interpolation. Lagrange's interpolation. And so this is actually the numerical. So in this actual solution of the equations and numerical integrations. So in this actually there are many methods. The numerical integration. So trapezoidal rule, Simpson's rule, Gaussian quadrature formula. Trapezoidal rule, Simpson's rule, Gaussian quadrature formula. Gaussian quadrature formula. And solution of ordinary differential equations in that Euler's and Runge-Kutta methods. In this actually Euler's and Runge-Kutta methods. Runge-Kutta methods. And then the next one is computer programming. In the computer programming, we have binary algebra, binary system, arithmetic and logical operations on numbers, octal and hexadecimal systems. Arithmetic and logical operations, octal and hexadecimal system. Octal and hexadecimal systems. Conversion to and from decimal system. To and from decimal system. Algebra of binary numbers, representation of unsigned integers. Algebra of binary numbers, representation of signed and unsigned integers. Signed and unsigned integers. Double precision reals and long integers. integers. Elements of computer systems and concept of memory. Concept of memory. Basic logic gates and truth tables, Boolean algebra and normal forms. Boolean algebra and normal forms. And the last one is actually algorithms and flowcharts for solving numerical analysis problems. Numerical analysis problem. Right. So this is the complete syllabus actually what we are going to learn. Right. Right. So this is the syllabus actually what we are going to learn. Now in this actually we can divide clearly into two different sections. One is completely related to numerical methods. Another is actually completely related to the computer programming. So it's not actually the programming. So you need to understand the basics of computer, how it works. So that is the only thing actually which is there as part of our syllabus. Right. Now let me go through this. So this is numerical methods actually solution of algebraic and transcendental equations of one variable by bisection, regular falsy and Newton-Raphson methods. And in this actually what we are going to learn is, suppose actually we know actually if there is any particular equation, that is suppose actually if I have this equation in a single variable, let us say 2x square plus 3x plus 4 equal to 0. Now that is an equation because there is an equal to sign. So obviously that equation actually you can solve like, so this is actually quadratic equation, and the quadratic equation solution we know how to solve it. But actually if the equation is actually is in a different format, let us say e power x plus x square equal to 0. Suppose if I give this equation e power x, right, plus x square equal to 0. Now actually I ask you to solve this equation. Now this kind of solution actually we cannot find out straight away with the help of our known methods, because we know how to solve only the quadratic equation. And even with three variables also actually there is no standard established methods. So even with a single variable of order 3, there is no standard established methods till now. So we go for the trial and error methods if the order is more than 2. So, but if it is a non-linear equation like this, actually, then definitely we cannot find out a solution, because actually there is no standard established method even in mathematics today, right? But analytically you may not be able to solve, but with the help of the computers actually we will be able to solve even this kind of equations also. For this actually there are different techniques that are available. Out of that actually these are the three different techniques. One is the regular falsy method and regular falsy method, bisection method and the Newton-Raphson method. And all these three methods actually they have actually their own advantages and disadvantages. That's why actually we learn all the three, and then actually we'll try to compare which one is actually more suitable. And most of the times actually we prefer Newton-Raphson method because actually that is far more advanced than the other two methods. Got it? And this is actually in the numerical methods actually you need to be clear on one point, that actually you will not get 100% accurate solution in any of the numerical methods, but you will get an approximate solution. So that approximate solution, suppose if the answer is 10, you may get actually 9.5 or actually 9.9 like that, but you will not get 10. Right. So in all the numerical methods actually that kind of thing is there. That's why actually there is a concept of an error in case of numerical methods. How much error actually you are going to get if you try to solve with that particular method. So that actually is a considerable amount of error. We will consider that the solution is not appropriate. So depending upon the accuracy requirement, we will go for the multiple iterations so that actually you will be better approaching the solution. Got it? So this is about the numerical method. So the fundamental difference between the analytical method and the numerical method is, so analytical method, either it will give 100% accurate solution or actually you will not be able to solve that. But in numerical methods, actually you will be able to solve all the problems, but approximate solution only you are going to get. So that's actually, so as an engineer, actually everybody actually prefers numerical methods because actually we want the solution, some are the other solution which is very close by. But rather than having not having the solution, so it is always advantageous to have approximate solution, right? So that's why actually we go for the numerical methods. And then actually, so solution of system of linear equations by Gauss elimination method, Gauss-Jordan method, and Gauss-Seidel methods. So these are actually standard establishment methods actually that we learn as part of linear algebra. So the matrix, matrix theory actually what we are going to learn is just to solve the linear equations. So linear equations are the one actually which is having the power of 1. Maybe involving multiple variables, but every variable is involved with only power without having any multiplication. That is, the standard format is ax plus by is equal to c is a linear equation. So x power 1 is there, y power 1 is there, but there is no multiplication of x and y. And powers has to be 1 only. In that case, actually, we call that as a linear equation. So, but the number of variables can be any number. You can have actually 10 different variables as an equation. Like that, if you have actually 10 different equations, you will still be able to find out the solution for each of the value, right? X, Y, Z, all those variables, right? Now, in this actually, there are different techniques that are available. So that is the Gauss elimination method is one technique. Gauss-Jordan method is another technique. Gauss-Jordan is a direct matrix method, and Gauss-Seidel method is an iterative method. So here actually, whenever we talk about the solution with the numerical methods, there are iterative methods and there are actually the direct methods as well. So most of the 99% of the cases are only the iterative methods. Even here also actually bisection method, regular falsity method, Newton-Raphson method, all the three methods are actually only the iterative methods. And Gauss-Jordan method is a direct method. That is actually you will be forming the matrix Ax is equal to B and you will solve for X by taking the inverse of A. So that actually we will straight away find out the solution and then actually it is a direct method. But in case of Gauss elimination and the Gauss-Seidel methods, actually it is an iterative process. So if you keep on do multiple iterations, you will get the accuracy more and more. But actually in some cases, actually the linear algebra problem is, that is with the help of this Gauss elimination and the Gauss-Seidel methods, as it is an iterative method, depending upon the initial solution what you are going to adapt. So that initial solution, somewhere you will have to start with some solution. So that solution actually, if you take it too far, then actually the solution may not converge. Even if you run for 100 number of iterations, at least still you may not be able to find out the solution. So there is one such kind of problem that exists in the all the iterative methods. That is, if the initial solution what you assumed is not very close, then actually you may not be able to get the solution at all. So you will be running thousands of iterations, but still you will not arrive at the solution. That kind of problem actually you are going to get it in case of numerical methods, because actually you are using the computer. So 1000 iterations or 10,000 iterations, actually it doesn't matter because computer can run all those iterations. So in that case, actually you will have to change the initial solution and then actually you will have to do it. But some cases, so 90% of the cases you will get the convergent solution. 10% of the cases you may not get the convergent solution. Got it? So that is a case by case analysis. That means actually you cannot argue that actually for this particular initial solution, why can't I get the solution? That kind of argument is not valid in case of numerical methods. Got it? And then actually, so the next one is actually Newton interpolation and the Lagrange's interpolation. So interpolation is a concept of predicting the future, basically. So that is actually if there is a data of points, a set of data points that are available, based on the set of data points, actually you wanted to identify at a future value what is the value, corresponding value for the other variable. That is, if I give y is equal to f of x as an equation, and that equation actually it is based on the some data points. So if you give actually the x value 0, 1, 2, 3, 4, you got the data. Then at x is equal to 10, what is the value of y, that you can predict it, even if you don't know the value of the function. But still the data points actually you can use it, and then actually you can try to curve fit it, and then actually you can get the solution there, right? So this is exactly what we are going to do nowadays actually as the artificial intelligence. So artificial intelligence is just exactly the same, that is the curve fitting, but with the multiple variables. So many variables that are there, but actually we will be analyzing only one variable or two variable relations. But in case of artificial intelligence, actually we take the multiple variables, and rather than fitting into the curve, we will exactly simulate the curve fitting with the data points. So that is exactly what we call as the That is the TensorFlow. There is Google actually released the TensorFlow, right, for the artificial intelligence, speech recognition, voice recognition, all those things actually just based on this interpolation concept only. Got it? And then actually, so there are two different techniques actually. These are the old techniques. There is the Newton interpolation technique and the Lagrange's interpolation technique. So these two methods actually we will use and try to construct a curve out of a set of data points. And this is actually the numerical integration. So the numerical integration actually we usually do by analytical method. We know how to do the integration with the help of the calculus. But here actually we use a technique. The technique is actually depending upon the accuracy requirement, we will try to approximate the curve. So the curve actually, suppose if this is the curve, so let us say this is the curve and this is x-axis and the y-axis, and then actually we will try to divide this into trapeziums like this. So this is a trapezium and then actually this is a trapezium. Then actually all these trapezium areas actually we will calculate it with the numerical methods, and then actually we will try to find out the total area, which is what we interpret that as the integration value. And depending upon the accuracy requirement, so there are actually advantages and disadvantages in the trapezium rule, and we go for a better accurate method, that is the Simpson's rule. And then actually we can even go further, actually Simpson's 3/8 rule. Simpson's 1/3 rule is one part, Simpson's 3/8 rule actually is another way. So depending upon the accuracy requirement, actually we go for the next level. The complexity involved is more if you wanted to increase the accuracy. So that is actually why the accuracy question that comes is, I'll give you a simple example. Suppose if I have a curve like this. So if I have the curve like this, now in this case actually, when you wanted to calculate the area, so this is how actually you will approximate it, right? Now, in this case actually, so we are approximating like this. Now here actually it is like a straight line, you wanted to approximate it, but the curve is actually like this. Now in this case actually the curve is of this complicated, but you still wanted to approximate as a trapezium. So this area actually needs to be counted, but we have not counted. This area needs to be excluded, but we have counted. Right? So such kind of problems actually will arise if you wanted to approximate as a trapezium. Now rather than this actually, if I try to approximate like a parabola like this, then actually the accuracy is much better than the previous one. So this is called as the, so that is the Simpson's 3/8 rule. So that is a, sorry, a trapezium rule to Simpson's 1/3 rule. Now if you try to approximate this as a curve like actually a third order equation, then actually it is going to be a much more accurate one. So that's why actually Simpson's 3/8 rule. So essentially you are trying to find out the area, but with more appropriate curve to fit exactly into the same kind. So this actually we will do with the different kinds of equations. Actually we take it and then try to apply these rules to find out the integration. And then actually, so that is, so trapezium, so all these are actually just based on one single formula. Actually we take it based on that, actually the master formula I will derive in the class, and that master formula actually we can use it to derive the trapezoidal rule, to derive the Simpson's 1/3 rule, to derive the Simpson's 3/8 rule as well, right? And all those things actually we will do it. And then actually, and Euler's and the Runge-Kutta methods, actually these are two popular methods, but rather than two popular methods, actually we say the Runge-Kutta method, actually there is a method called Runge-Kutta's fourth order method, which is more popular in engineering. So that is actually we use, as and when we require to solve a differential equation, we straight away use Runge-Kutta fourth order method itself. This is one of the numerical analysis technique to find out the differential equation solution directly, because we wanted to solve the differential equation. So solution is nothing but, suppose if I have this equation, that is dy by dx. So dy by dx is equal to, so this is actually, let us say y, and this is the differential equation actually we wanted to solve. But solution by definition, what we wanted to do is y actually you wanted to establish as a function of x. Now this relation, rather than expressing as an equation, you can even express as a set of data points. That is, for this, so if x is equal to here and then y is equal to here, and this is, when x is 0, corresponding y value, and x is 1, corresponding y value, and when x is equal to corresponding y value, if you give you a table of data points based on this equation, then it is as if like actually solving the differential equation. So that is how we solve the differential equation with the help of the numerical methods. So solution meaning you cannot get this particular equation. You give your data points like this. So this actually will give the solution for this particular one, and then actually at one particular value we are mostly interested. Suppose actually given this differential equation at x is equal to 5, what is the value of y? So that question actually is nothing but the solution of the differential equation for us. And for that actually we will use Runge-Kutta methods, and that also actually we will derive how the Runge-Kutta method actually came into picture and how accurate actually it is going to be there. So that actually we will derive in the class itself. Got it? and this is the solution of the differential equation. So till this point, actually, these are the ones actually we are discussing as part of this numerical methods. This is actually very simple and short syllabus. It won't take much time. So most probably I might finish everything on numerical methods within 10 hours. Got it? Any questions on this? You can tell me. Any questions on the syllabus of numerical methods? Yes or no? Right? Okay, fine. So on the next part is actually the computer programming. So basically in the computer programming, if you people are from electronics background or computer science background or electrical background, and even if you are from mechanical or civil engineering background, if you study computer science as one of the subject, the digital electronics actually is the syllabus what he has listed here. So simply the digital electronics directly. That is actually the, so in the entire engineering, all the engineering fields, digital electronics is the one which is the most easiest subject, most easiest among all the subjects of all the engineering, right? So this digital electronics actually, it is basically actually playing with the numbers. So we need to understand actually how the numbers came into picture and what are the different types of number systems, how we can derive those number systems, and how you can do the mathematical calculations with the help of those number systems. This is the basic understanding we are going to do. Most probably we will be discussing on the decimal number system and the binary number system. And these number systems are the basis for the humans as well as the computers. So that's why we will try to understand these two number systems, and we can make use of these number system methodologies to even derive the other number systems like the octal number system or the hexadecimal number system, or so base 10 or whatever it may be, you can take it, and any number system actually you can derive. Got it? And then actually the operations also automatically corresponds to the operations, that is the conversion actually you always to have. That is actually decimal number system we are very much familiar with. And if you want to convert that into hexadecimal, you should be able to do that. Similarly, a hexadecimal number system actually you have taken one number, and that if you want to convert into decimal or if you want to convert into binary, you should be able to do it. So that methodology actually, so there are common methods actually that are available across all the number systems, which you can make use to convert from one number system to any other number system. So that actually we'll be learning as part of these number systems. And so logical operations and the arithmetic operations. So that is actually whenever we wanted to do some kind of programming, we always do only two different kind of things. One is actually either you wanted to do the logical operations or actually you wanted to do the arithmetic operations. Arithmetic operations meaning addition, subtraction, multiplication, division and all. And logical operations means actually you wanted to take the so that is the decisions. So the decisions is nothing but supposedly, so suppose if rain is coming, then there is no class, right? So this actually, if condition is there, if rain comes, then no class. So that actually is called as a logical thinking. Here there is no mathematical aspect. It is pure logic. If the rain comes, then there is no class, right? So this is how actually we use the logical operations. Even the binary number systems actually we will interpret as the true and false, because binary number system will always have only two different numbers. So 1 and 0. So 1 can be treated as true and 0 can be treated as false. And based on these two actually you can do even the arithmetic operations and the logical operations together. It's not that actually in the case of a decimal number system you can do only arithmetic operations. Logical operations can't be performed with the help of the decimal number system, because logical thinking is always either true or false. Only two possibilities. But we have actually 10 different possibilities in case of, right? So we have actually 10 different possibilities in case of so our decimal number systems. So that's why actually it won't be fitting for the logical operations. That's why actually we are much more comfortable with the binary number system. And this binary number system actually, so it is a bit difficult to understand a bigger number. That is, suppose actually if you wanted to write 100, then actually it is actually so maybe almost I think so I think 16 digits or somewhere actually you are going to get it. And that many number of digits actually you, by looking at your high and try to understand whether it is going to be 100 or not, the decimal equivalent, that is a bit difficult. Rather than that, actually, if you can express into a small number, suppose actually FF if I give it, FF is nothing but 256. FF is actually the hexadecimal number system. So hexadecimal number system actually, it will be using the shorter notation to represent the bigger numbers. But it is more convenient to express binary into the hexadecimal number system. But we are familiar with the decimal number system. That's why actually decimal number systems actually is a medium to understand actually our human brain. But computer is actually more comfortable with ones and zeros. That's why actually binary number system is meant for the computers. And to interpret by human brain, actually it is convenient to use the octal number system or the hexadecimal number system. That's why we are stressing a bit more on the hexadecimal and the octal number systems. Got it? So that's why we'll be learning all those things. But trust me, it is one of the very, very easy subject. Got it? And then actually, so this one, so Boolean, so decimal number systems and algebra of binary numbers, and so this is representation of signed and unsigned integers. That is actually, so in the arithmetic operations, actually, we wanted to do the addition and subtractions. Now here actually, there are negative numbers and there are positive numbers also. That exists in every number system. Now in case of binary number system, actually, as we are using only zeros and ones, so, and if you wanted to do the operations also, then actually how the negative sign is going to be interpreted or the positive sign is going to be interpreted, because actually it is purely a mechanical equipment which have to do the operations. So minus, actually our human brain actually can understand. So this dash actually represents the minus, and we know that actually how to subtract one number from the other number. But how computer recognizes? For that actually you should have actually some kind of technique to feed into the computer how the negative number is represented, how the positive number is represented. For that actually there is a methodology that we are going to use it. So that is actually, so leading number actually we take it for the sign, or else actually there is so 2's complement or 1's complement techniques. Actually there are other techniques that we are going to discuss down the line which can be used to represent the negative numbers. Got it? And that actually we will be discussing how to represent the negative numbers. And then actually elements of computer systems, and that is the computer system actually usually any computer actually will have some basic components. So the components are actually, there will be a CPU, which is what we call as the central processing unit, and we should be able to give the input to the computer. So that's actually the input devices has to be there, like the keyboard and mouse, and the output device. Output device is like actually the screen actually what we are going to see, or actually if you print it, the printer also actually it can give the output what is there in the computer. So the printers and the screens actually we call that as the output devices. So input output devices, and also actually it has to, the key part is actually in the computer is the memory. So the memory is actually, it is so to store certain amount of data. What kind of data it is? It can have actually multiple types of data. So nowadays actually we have infinite variations of the data, like the pictures, videos, and the data. So text. So different forms of text. All those things actually will be storing in the computers, right? And these things actually to store in the computer, there should be some way of storing, right? So it has to remember. But how to remember? So our human brain actually it will store, and as and when it is required, we will be bringing out, right? So because actually I have prepared for the class, that's why actually I could able to teach. So preparation is actually feeding into my brain, and then when I'm teaching, then automatically it comes out of my mouth, right? Now this process actually how in the computer it is going to happen. So what is the concept of memory? So memory is nothing but, suppose actually I'll take a simple example. What is a memory? So see this actually, suppose I have a capacitor. Here is a capacitor like this. Now actually I will connect to this particular battery, and then actually I'll store the charge on this particular capacitor, and then actually I will remove this particular battery. Now the capacitor actually is charged. So it is charged. Then actually, so I say that actually if it is charged, then actually I say that this is going to be 1. So this is going to be 1. 1, or actually it is having the higher voltage. Certain amount of the voltage is present. Even if I remove this particular battery, still the capacitor actually stores that particular charge. And as and when actually I come back, suppose actually tomorrow if I come back, then actually if I check the voltage, then actually I see that there is a higher voltage that is present here. It is as if like actually yesterday I have given certain voltage to this particular capacitor, and today I came back, and then actually if I check it, then actually there is the voltage that is available. That means it could able to remember that there is a storage of voltage. Got it or not? This is exactly what we call as the memory. And this concept actually we will extend, and this extension actually can be so multiple level actually we take it. There is the gigabits or actually megabits, all those things actually only these kind of capacitors actually we keep it infinite in number, and then actually we will use that to store different numbers. Got it? So this is exactly what is the memory that is going to working in the in the computers, right? So there are different techniques. You may use only the computer, so only this one capacitors, or actually you may use the diodes to do the same kind of purpose, or you may use some other device like MOSFETs, you can use it and to store the same kind of information. So essentially it is storing the information in a form of certain amount of the voltage. You are just actually charging it, and then at a later time actually if the charge is there, you interpret that as 1. If the charge is not there, you interpret that as 0. So this is how actually we keep the memory, right? So this is the concept of memory. And this one actually, so this is And so to represent actually the double precision reals, there is the real numbers, actually the decimal numbers that is going to, sorry, if there is a decimal in between the number, even for the binary numbers also, then actually how to interpret the real numbers in case of the binary number system. So that concept actually we will have to understand. And I see that actually there are questions actually that is coming in this real numbers with the binary, right? So, and then actually elements of computer system, concept of memory, and basic logic gates. So logic gates actually, so these are actually a graphical way of representing the our human brain interpretation of logical thinking, basically. So that is actually we do with the help of these logic gates. There are certain aspects actually, if both, suppose actually, if two events are there and you wanted to take the decision based on the two events, so there are different cases. So if both have, suppose actually, if a lecturer comes and the students also comes, then there will be a class. So here actually there is an uncondition. Lecturer also has to come and the students also has to come. So in that case only the class is going to happen. And this is what we call as an AND gate. In some cases actually, so whether the students comes or not, the faculty actually will be taking up the classes because actually it is going to be recorded. Here actually there is no necessity of students being present here. So here actually R and R. But the faculty is not there, the class is not going to happen. That is a different case. But actually, so if one of the operation is true, then automatically the result is going to be true. Then you call that as the OR gate. And in some cases actually, so NOT gate. So if this happens, this is not going to happen. That is actually, so if the class happens, recording will be there, right? If the class doesn't happen, recording won't be there. So here actually there is a kind of NOT operation. If this happens, the automatically actually the other one is opposite to this. So that is what we call as a NOT gate. And there are other gates like exclusive OR gate and then actually exclusive NOR gates, NAND gates, and then NOR gates. Actually there are different types of gates actually, which are purely based on decision making for different kind of scenarios. All those things actually we will be discussing it here. And so that actually we will be discussing as part of this logic gates. And the truth tables actually is just the interpretation in the algebraic way. So that is actually we take the tables for the AND gate, OR gate, NOR gate, NAND gate, and exclusive OR gate. All those things we will try to understand in terms of the truth table. And the last one is, and very important part is the Boolean algebra. So this Boolean algebra actually is like actually we know how to deal with the algebra in case of normal algebra. But this algebra is not a simple topic. So that is as and when we have a set of symbols, we have a set of operations. Then actually each operation with a set of symbols actually the result actually is going to be defined, right? And this is actually a certain rules actually that is going to be there to perform certain operations. And this is what we call as an algebra. And there are different types of algebra. We have actually in our normal algebra, we have addition, subtraction, multiplication, division. All those 4 symbols actually with the numbers that is 0 to 9. All the 10 symbols actually we use it, and the addition, subtraction, multiplication, division 4 symbols actually we use it, and we do all the kind of mathematical operations with the help of these 10 symbols which are called as the numbers, and the 4 symbols which are we call as the signs, or actually which are the mathematical operations, right? And exactly in the similar manner in vector algebra actually we learned. So in vector algebra, if you notice, so that is a different kind of algebra, still to deal with a different type of system, that is actually the vector addition, subtraction, multiplication actually we do it. But actually if you notice, there is no relation between the normal algebra and vector algebra. So there is an addition in the vector algebra, there is an addition in the normal algebra, but these are actually no way related to each other. And similarly, if you notice, there is a subtraction in normal algebra, there is a subtraction even in the vector algebra. There is no difference between these two. So there is no relation between these two at all. But if you notice, the multiplication in normal algebra is only once. But actually in case of vector algebra, there are 2 different kind of multiplications. One is the dot product and there is the cross product. Okay. So, but the division, if you notice, division is there only in case of the normal algebra. Because it is not having any application in case of the vector algebra, we have not even defined what is the division, because any application actually will, so that is the application is the one which will derive any particular operation. Here actually there is no application for the division in vectors, that's why actually we have not defined anything related to division in case of the vector algebra. Exactly in the similar manner, there is one more algebra actually we are bringing in, that algebra to deal with the binary numbers. That algebra is the Boolean algebra, right? So now actually 1 plus 1 actually we always call this as actually in case of decimal number system 1 plus 1 is 2, right? 1 plus 1 is equal to 2. But in case of Boolean algebra, 1 plus 1 is treated as 1 itself. That is, the plus is treated as an OR, and 1 is treated as true, and another one is treated as true. So true or true, the result is true. Like this actually, there are certain rules actually we will be defining in case of this Boolean algebra. And with the help of these Boolean algebra rules, actually, you can simplify a complicated decision making tree into a small one. Basically, actually, why this Boolean algebra is required is, suppose actually there are hundreds of logical operations that are present, let us say. So logical operation is either true or false. So even though if you have actually, see this actually, suppose actually if 100 people are in a meeting and everybody is having certain opinion, right? Certain opinion on certain aspect. I mean, this actually finally the outcome is whether to do that work or not. So this is the final outcome. So that means if you wanted to do that work, then actually it is true. If you are not doing the work, that is false. So even if 100 people discuss with different opinions, final outcome is either true or false, right? So now in that case, actually 100 people opinions to collate and finally bringing into a single output. So this actually, all these opinions actually will put it into a logical operation. All those logical operations are simplified into a single outcome, and that's what we use the Boolean algebra to do all such kind of things. Got it? So suppose actually so A plus B, if A is true, B is true, then actually the output is actually true, right? But suppose actually A plus B into C plus D into E plus F. Now here actually this is one decision, this is one decision, this is one, this is one, this is one, this is one, and all these operations together actually it is resulting into one particular output. Now how to simplify this into a single true or false? That actually we use the Boolean algebra. Got it? And in that actually, so this Boolean algebra is a mathematical way of analyzing the decision tree. But the same thing actually, if you wanted to interpret and you wanted to make that decision by a computer, you will have to put into the logical format, and that needs to be designed with the certain amount of the electronic devices. So those electronic devices are designed based on these logic gates. Logic gates are nothing but actually the electronic devices like the transistors, diodes, and thyristors and all. Those things actually we will use it, and then actually we take the input as the electrical signals. All these decisions actually as the electrical signal. Final outcome also it will come as an electrical signal, and that signal actually we will take it, and then finally it will present the output. And for that reason actually this Boolean algebra we will try to interpret with the help of these logic gates. And in that process actually a complicated decision tree is simplified with the help of, there is something called the normal forms. So these normal forms also important even from our UPSC perspective also. Got it? So this is the complete syllabus actually what we are going to learn as part of this particular topic. So tell me if you have any questions on this. Questions? Right, so this is the complete syllabus, and then actually, so syllabus I have discussed, and then actually what are the books that needs to be followed. So for this actually the numerical methods actually BS Gravel is enough. Right, BS Gravel actually that you can take it for the numerical methods, but computers actually, so that is the computer programming part actually. So you will not find any particular book actually we have given in our material that should be useful. But if you people are actually from electronics background, then any book actually what you have studied in your graduation that will work. But if nobody, so if somebody actually has not studied this digital electronics, then actually there is one book actually, Digital Electronics by Paul Malvino Leach. Right, so Paul Malvino Leach actually, this is actually one of the very easy book. That's why actually I suggested this. But people might have studied Kohavi or something like that. That is not, that level of standard is not required. So this book is actually very easy to understand. This standard is more than enough for us. Got it? So this is Digital Electronics by Paul Malvino Leach. And then weightage of this particular topic actually, this is 70 marks weightage is there for this particular book. So for this particular topic. And then actually important sections actually. So in this actually, one is, so the trapezoidal rule actually is one particular section, trapezoidal or Simpson's rule actually for doing the numerical integrations. And the Runge-Kutta methods is important from the examination perspective. And other aspect is actually, so regular falsy method actually sometimes actually they used to give it, and the Gauss-Jordan method. All the methods actually, as these are applications perspective, and more inclined, so UPSC actually is more inclined towards this particular topic because it is more of computer application for the engineering problems. So if you notice the UPSC philosophy is actually more of application oriented questions only they give it. And this particular topic actually is more related to the real-time world. So that's actually every section is important in this particular section, right? So in this particular topic, every section actually is very, very important. And it is easy to understand also. That's why actually you will not face much of difficulty, correct? And then actually approximate number of hours actually, as I told you, numerical methods actually I will take it around 10 hours, and digital part actually I will take around 5 to 7 hours. That's it. Got it? Any questions? Got it? Yeah, that's all. Thank you.